309 people were randomly selected and their eye color and gender were recorded. You see the data in the given table. Now we are going to answer questions A through E about this table. First question, what is the probability a person is female and green-eyed? Keyword here is and. So when you're looking at the female, green eyes, we come up with 18. There are 18 people who are green-eyed females out of the total 309. So as a fraction, right, that's an unreduced fraction, I'm going to go ahead and change everything to decimals to 3 decimal places in this problem. So the probability of selecting a female and green-eyed person is 0.058. Part B. What is the probability a person is blue-eyed given the person is female? So now we're saying we only care about the females. You know you have a female because it's given. Given the person is female, what's the probability that you have a blue-eyed person? So we are looking for the blue-eyed over the total females because you're given that it's a female. So, well, only looking at our females, how many blue-eyed people do we have? Well, 61. So there's 61 blue-eyed females out of 162 total females for a decimal approximation of 0.377. Letter C. What is the probability a person is brown-eyed given the person is male? So now we're given male. So we're only looking at the male column. So now I'm looking for brown eyes over the total males. Well, how many of them have brown eyes? Well, that's here. So I have 72 over the total males of 147. So when you see the word given, or sometimes the word if, right, that tells you that you have conditional probability, meaning you're selecting an individual group, and in this case, we're selecting the males, right? So 72 out of 147 gives me a 0.490 probability rounded to the nearest thousandths. All right, part D. What is the probability the person is male given the person has green eyes? So now we're talking about just the green-eyed people. So we're talking about the males out of the total greenies. So, okay, no problem. Let's look. Green, here's the males. So I have 21 of the males out of 39 total green-eyed people. So whatever follows the given, that's what's going to go in your denominator. So, because that's where you get your total. So 21 over 39 gives us a 0.538 probability rounded to the nearest thousandths. And last but not least, part E. What is probability the person is female or blue-eyed? So now I'm going to an or instead of an and or a conditional. So I want to know the probability of the female plus the probability of somebody being blue-eyed, and I'm going to subtract the probability of blue-eyed females. So blue and female. Because when we have the word or implies addition in probability. But think about it this way. If I take, here's the probability of my females, here's the probability of my blue-eyed people. Notice how these guys are counted twice. They're in both the light pink and the burgundy. And so you're counting them twice. That's why we have to subtract the blue-eyed females because they are causing an overlap. So first I take my probability of selecting a female. I have 162 females out of 309 people total, right? Probability of female over the total. Plus, what about my blue-eyed people? Well, there's 115 of them out of 309. And we just talked about the overlap. We want to take out the 61 people that we just counted twice. We counted them as part of our females, and we counted them as part of our blue-eyed people. So when I do that, my numerator is 216 out of 309. Okay, well, 216 out of 309 gives me a decimal approximation to the nearest thousandths of 0.699. And there's the probability of selecting a person who is either female or blue-eyed.